everyone wants to sit down. If you're looking for the panel on 50 years later, the pipeline significance to Alaska, you're in the right place. I'm Lisa Weissler. I'm moderating this wonderful panel. And just before we start, just give a thought here. I mean, Governor's insights were so excellent. And kind of thinking back to 1968, when oil was first discovered up in the North Slope, and the oil companies were looking at building this 800-mile pipeline from the North Slope all the way to a southern port in Alaska. And the problems that they were facing had to have seemed just insurmountable. I mean, you had economic, technical, environmental, political problems. And yet, people got it together, the scientists, the engineers, the people working hard on the ground. And here we are, amazingly, 50 years later, having this discussion on the service of a pipeline that is still functioning and talking about the significance of it for Alaska. So what we're going to do today, we have this panel. I'll give introductions individually before they speak. We have Greg Kinney, Phil Wight, and Tim Bradner. They'll each have 15 minutes to do their presentations, and then we will have questions afterwards. So be thinking about that. So to start things off, especially given thinking about this remarkable accomplishment of this pipeline and how it's still running, we have Greg Kinney. He grew up here in Fairbanks. From 1975 to 1977, he worked on on the construction of taps as an oiler. In 1982, he graduated from here, from UAF. He's a registered professional civil and mechanical engineer, and he's now working at Alaska, where he's worked since 1989. He's working as a site engineer in the central and southern portion of the pipeline. So, very appreciated.
What's under, is there anything?
So this, we're on the, first off, I want to express my appreciation to the Historical Association and to Philip in particular for the invitation to tell this story. For me, this is my 50th anniversary on TAPS this particular month.
There were some
just because, I mean, many of you have stories like this, but I, flew into Franklin Bluffs camp just the day after Labor Day. This was like the third try getting in there, and to start my 9-week on and 2-week off, rotation, where I worked the next couple of years, and then went to school, got my engineering degree. Didn't have anything to do with it until 1989, but that's where I've been parked ever since then. Working various issues. Now we're going to do the Wayback Machine.
Gets me there.
Oh.
Try to talk about our maintenance challenges. Philip posed a number of topics for us to talk about today, and there's a couple, well, 3 of them that I will dwell on. One of them is maintenance challenges. How has our maintenance evolved over the last 50 years? Environmental challenges, how have those changed? Then thirdly, the term life was done, but I'm going to use the term outlook. So therefore, that's my topics. And there's our pipeline there going from Prudhoe Bay to Valdez. So talking about maintenance, what do we do? Why do we do it? And we'll talk about the challenges of the early years and then how those challenges have changed over time from a maintenance perspective. So what we do and why we do it. As you know, Alaska was formed as a consortium initially of 7 oil companies, with Ohio being the senior, largest percentage. And the charter for Alaska Pipeline was to construct, operate, and maintain the pipeline. So the overwhelming challenge at first, obviously, was construction, which has been dealt with at length in various conferences. Most of you are probably familiar with that story. But the maintenance and operation of it is also not trivial. We do have a 48-inch pipe. It's unavoidable going across Alaska. You have a lot of geographical obstacles to overcome. We have to cross seismic zones. It's unavoidable that we have streams, permafrost, everything. Also, and this is very crucial to how we operate today, we have to operate over a wide spectrum of flow rates, whatever essentially the owners deliver to us, or the producers, I should say. Our mission is to get that to Valdez and then escort them the next 120 miles or so out to Hinchinbrook entrance via serves. So early challenges, and I'm going to divide our history into basically two points here. One of them is the 1977 to 1982 roughly time frame, the first 15 years, and then everything since then. Now, we peaked famously in 1988, which is a little before that 15-year period. But one of the things we had to deal with extensively throughout that period was ramping up throughput. There was a managed decline shortly afterwards. By the way, I came on board in 1989, so essentially it's been on decline my entire career as an engineer there. The other thing was thermal, which we'll get into in a bit here. So our growth challenges were very significant. We had to bring, we had 12 pump stations initially planned, 11 of which were built. And we were going to have a main pump unit at pump station 5. That never had to be built because we had this thing called DRA, or drag reducing agent, that allowed us to flatten somewhat the friction loss of flow through the system. But, there was a lot we had to do in order to accommodate that in terms of phase 2 facilities, pump optimization and things like that, as well as DRA injection. Another major challenge that we had during this period, I'll just call it thermal challenges, because we had hot oil. At those flow rates, I mentioned that, you have friction losses, or we call them head loss, through the system. It's very steep, and therefore you need frequent pump stations, especially where you're pumping uphill. And with friction losses, that shows up as heat energy. The hydraulic energy becomes heat. You're heating up the oil as you're going along, and plus you're heating going through pumps. Well, with hot oil, it's arriving at Valdez at 100 degrees, you're going to get corrosion or at elevated rates if you get a film of water next to the pipe. That nipped us. This picture happens to be the Adigan reroute project in 1990, 91, roughly, where we ended up replacing 8 miles of pipe. The other thing we had to deal with was thaw settlement. And generally, we had a great job that was done in the initial geotechnical exploration, identifying areas where we would have thaw stable versus thaw unstable permafrost. Thaw unstable being there's enough ice in there so that if you have hot oil from the pipe, buried pipe next to it, it would settle. That's where they would prefer to go above ground. And in fact, most of our pipe is above ground, 420 of the 800 miles. So it's only really where we kind of, missed it during the exploration. That happened in a couple of places on the mainline pipe. Also at pump stations, we had some of these difficulties too, where we had to, jack up the pipe and put them in insulated boxes. And that carried on, to, the early 90s. There was no clean dividing time. But, there's a second period, which I'll call maturity and throughput decline, where some of our challenges changed. And part of it was just managing that decline. So if you start moving that curve over to the your right over there, we're tailing off to about 480,000 barrels today. We have to reduce the facilities, not just from a cost standpoint, but also the hydraulic energy would be nothing but wasted. You really couldn't do it. So you had to reduce the number of pump stations. It also made sense to consider, how do we deploy our facilities? And that became a focal point, starting in the 1990s and going on through arguably even today at a slower rate. The other major challenge that we have here is as we move into our more mature period, is that some of our equipment begins aging, wearing out, and we have to replace it. Now, this is probably the most spectacular example of it, a project we call strategic reconfiguration. This happens to be Pump Station 9, which is just a little south of Delta. And there are sort of darker green modules that were installed in the roughly 2006 timeframe to replace the lighter colored green, main pump building that's in there. So, now, some of those facilities do remain in service. But that, that's a renewal that we ended up doing, and it was very important to us. Most of our replacement is, less spectacular than that. There's equipment obsolescence. Now, when manufacturers use that term, it's about they just don't make it anymore. Then later on, they won't support it. But for us, it's more a matter of, can we support it? Do we have the training to do it? Do we have the spare parts? Is it something we can continue to operate? If not, we need to replace it before we have to. So then the other thing, I use the term oversized components in there. Well, what does that mean? Well, the 48-inch pipe is certainly oversized to our current demand. It would be optimal if it was less diameter, but they had to make that choice in initial construction because they were trying to accommodate the maximum throughput they possibly could to recover their capital investment as fast as we can. They would have gone to a larger size pipe if they could have. 60 inches, they would have done that. Now we're only glad it's only 48 inches. So, it would be nice if it was less. But it would not be cost effective to replace. Our job is to do the best we can and to operate it optimally. And I think we do that. So just one more thing in terms of more recently, because it does take a lot longer for the oil to get from Prudhoe Bay to Valdez. If you think of the 48-inch pipe, you have an 800-mile sort of heat exchanger where you lose heat. Well, that gets to be a little much in the winter. We end up having to put in, and we have several heating stations that we've installed, plus we recycle oil at a couple of other pump stations to add heat to it. That's part of our management strategy. So what drives work today? I'll divide them into two things: system and equipment processes and natural processes. In terms of system and equipment processes, I'll confess up all here, I missed a bullet. One of them is just sort of process variables, I'll call it, which is flow rates. We have to accommodate flow rates, crude composition. For example, if we have additional natural gas liquids, those are all things that have to be managed appropriately. And so in engineering side, and we support maintenance and operations to optimize TAPs. We have to plan for that. Another issue for us is just ongoing life cycle replacement. Most of it, for us, we're a combination of a lot of big things, or a few big things, but a lot of really small things. The boiler that needs to be replaced because you have cracked headers or things like that, controller that needs to be replaced. So we're about continuous improvement. We have technology improvements that we're looking at, especially in the communications arena, and that is a big driver of our work. Natural processes, well, there's a lot of natural processes, and corrosion is one of them. But a couple of them that are big but episodic would be flooding events that we end up having to manage, and that will drive a lot of work in a lot of cases to react to that. Seismic events, well, we really only had one. That's the 2002 Denali Fault earthquake. And it just happened to be this area here where it was planned for correctly. That design actually accommodated the kind of movement that we had. So it's been viewed as kind of the final exam of our right-of-way renewal that Dave Norton was involved in. And by the way, a shout out to the University of Alaska in Fairbanks. We work with the Alaska Earthquake Center on our earthquake monitoring, as we do on other monitoring issues, notably some of the geotechnical issues that we'll talk about. So this is probably a most important slide of all from the engineering standpoint, which is we are in the engineering and maintenance fact-driven. We have to do our maintenance based on the conditions that exist. Every now and then you might have a vision thing about where the company might be going and all of that. But the main thing is, how are we monitoring our variables? There's fast monitoring for things like process variables, like flow, level, and things like that. But a lot of what we do is a lot slower. That's the slope monitoring, things that UAF is helping us on. This picture is of a magnetic flux pig that we run that every 3 years. Those are inline inspection tools to detect corrosion anomalies. And we get that information. We can see what the remaining wall thickness is, and do we need to do any kind of remedial action? Are there areas that we need to pay attention to? So briefly on some of the other topics here, how has our environment changed over the last 50 years, and how might that affect our future? We talked a little bit about our permafrost challenges early on, having to do with oil around the hot oil in buried sections of the pipe. Those kinds of challenges have now basically gone away. You can never say never, I guess, but the oil is a lot cooler than it used to be, so you're not driving as much heat into the subsurface. But with changing climate, and it is warmer than it once was, we're getting additional thawing depth from the surface. Importantly, winters are longer, or they're shorter than they used to be, and the temperatures in the winter are higher, meaning that some of our tools do not work as well as they used to, notably like heat pipes. So it's not that they don't work, it's just that, you know, we have to do additional monitoring, and, you know, we end up having to work on it. So one of the topics here that we have to pay attention to is slope creep. There's an area that we're called a frozen debris lobe, where the Dalton Highway has had to be moved. The pipeline is, you know, quite a number of years away from that, but it's, you know, it's something where we're beginning to think, okay, how can we affect the progress of this? Is there any feasible solution we can do? So another topic environmentally is that lower crude temperature does affect the corrosion rate externally. It's lower than it used to be, so we have less of that corrosion. But there's other variables that continue to drive the work, like you know, seismic events, if they happen, or, you know, flooding events. There's nothing we can really do to affect that, and it's more or less the same frequency that we had before. Long-term outlook. Well, initially we had a 30-year right-of-way renewal, or right-of-way. That was considered the design life of TAPS at that particular point in time. As it turned out, we were quite viable as an entity going into that, and the renewal was accomplished, I believe, in 2003. Yep, Dave Norton was one of the key players in that. We're at the point now where we're almost 30 years later, and, you know, another renewal is on the horizon. In terms of what is the life of the pipeline, well, you know, the useful life is maybe an economic term. For us, it's, you know, we're going to maintain it for its useful life. That's our commitment. We're going to maintain it in a safe and reliable condition as long as that is useful. So that is our commitment. That's all I've got. I'll turn over to.
When, after my doctor's.
Oh, okay. What doctor?
So you can stay out of the way of the.
Sure about my shoulder.
Okay.
Thank you very much. Very interesting. Next up, we have Phil Wight, who, as you know, he's an associate professor of history in Arctic and Northern Studies here at University of Fairbanks. He wrote his doctoral dissertation on the history of the Trans-Alaska Pipeline System, and he's finalizing a book on TAPS that was based on his research, which I am really looking forward to reading. He's also written histories of Alaska electrification, a history of nuclear power generation in Alaska, and to add to all of that, he also works part-time for Alaska Public Interest Research Group over the last 6 years, where he helped author community solar legislation and helped get it to successful passage. He also just got back from delivering testimony to the U.S. House of Representatives Natural Resources Committee on Alaska Natural Resource Development. So I turn it over to you, Phil.
Thank you, folks. And Greg, I'm so glad you went first, because I feel like you hit so many of the essential highlights. Let's see, do I have? Okay, I won't. My slides aren't. Here we Nope, it's a different one. Here we go. Let me pull this up. Okay, thank you. All right, so many places to begin this story, so many different things that we could talk about. Maybe I'll start in the story in May 2017, when then Secretary of the Interior Ryan Zinke visited Alaska's North Slope and at the start of TAPS, right next to Pump Station 1. And he put his hand on the pipeline and, quote, pledged to fill the pipeline. And this was followed by a secretarial order to open up more areas for oil and gas leasing. And, a similar version of this happened recently in June of this year when Secretary of Energy Chris Wright visited the North Slope and promised to double the throughput of TAPS. And these acts of political showmanship around the pipeline show that the throughput of TAPS is far more than an economic indicator for Alaska. The pipeline itself became the gauge not only of the state's revenues, but for the economic consciousness of its people. And especially as the pipeline's throughput declined after 1988, as Greg talked about, and low oil prices persisted throughout the 1990s, conversations constantly swirled about how much oil was, quote, in the pipeline. And in the 2010s, this concern transitioned into fears that low throughput threatened the very viability of the pipeline itself. Now, as we all know, the pipeline is always full, right? It's not like it's humming along there at a quarter through, but it does move slower when it is not, operating at the 2.1 million barrels a day, which was the peak in 1988. So the main argument that I want to make today in the brief 15 minutes that I have here, and most of this will be focused on our Q&A afterwards, is just that the pipeline's design, going back to the late 60s and early 1970s, reflected certain temporal and spatial trajectories of North Slope development and corresponded to the pipeline's lifespan. Okay, what do I mean by all of this? This is really focused on geography and change over time. So many of the challenges that Alyeska and the owner companies are dealing with today are the legacies of historical decisions made in the 60s and 70s. The diameter of the pipeline being a key consideration, right? As Greg mentioned, if you were to build that pipeline today anticipating 500,000, 750,000 barrels a day, you would never build it at 48 inches of diameter. So I'm going to talk a little bit about that historic decision and also the kind of vision that the owner companies had about which hydrocarbon resources would be extracted, right? The design of the pipeline was fundamentally connected to that larger geography. So just as Greg mentioned, when the pipeline was first proposed and eventually the right-of-way signed, the vision was that this was going to be a 25 or 30-year lifespan or project. And of course, that's reflected in the right-of-way. 30-year right-of-way. And, sometimes, I've seen documents from the Government Accountability Office that talked about 35 years. There's one document in 1977 that said service life for pipelines is more of a function of the productive life of the oil reserves than a function of equipment lifespan. Right. So from the very beginning, folks were thinking, hey, this is really about the oil that's in the ground rather than some artificial date, 25, 30 years for the pipeline itself. One thing that I found really fascinating is that some of, so many different folks who had opinions on the pipeline, right? Conservationists who opposed the pipeline, people like Wally Hickel, who obviously wanted it developed. And one of the interesting things is one of those people who opposed the pipeline was David Brower. He was head of Friends of the Earth at the time. And Brower's perspective on this is really fascinating. He said that North Slope, he actually wanted a lower throughput. He wanted a smaller diameter line so that it would last longer. Okay. And his idea was that we should, quote, develop the oil resource slowly, carefully, and with environmentally and economic conscience so that the rewards are stretched out over a century or two or three rather than 2 or 3 decades. Right? Oh, this is really surprising. This is why history matters, right? This is why we got to go back to the primary sources. And fascinatingly, Wally Hickel had a pretty similar perspective, right? Hickel wanted this resource to last for a century or longer for Alaska, right? Rather than this short-term boom and bust that we had seen so often in the state's history. And central to the lifespan of the pipeline was the question about the diameter. And the decision to build a 4-foot wide pipeline with a maximum throughput of over 2 million barrels a day reflected certain assumptions and future aspirations by the oil industry in the development of the North Slope. So TAPS owner companies did consider a smaller diameter line. And line sizes of 36 inches or 42 inches may be preferable. This is coming from the December 1968, the Gold Book. I wonder if you guys have like an original version of this. I've always wanted to see that. And so 48-inch diameter was ultimately chose for financial reasons. And based on, basically the owner companies calculated that the wider the pipe, the more oil could be shipped, the faster the owner companies could realize profits, even with a high discount rate. And as Greg mentioned, they actually wanted a 60-inch diameter line, but there wasn't a steel mill in the world that could produce that diameter pipe. So they went with 48 inches. And in that original agreement, both in, I think it was in the Gold Book, but it was definitely in the owner's agreement, 600,000 barrels per day was considered the minimum design capacity of TAPS. So from the very beginning, the owner companies knew, hey, if we do this 48-inch diameter pipe, we're going to be able to move a lot of oil really quickly. We're going to be able to get a return on our investment, but there is going to come a time in the future where this pipeline is actually going to be much harder to operate because we designed it so large, right? And this was right there in some of those original documents. A wider pipeline was also seen as an explicit strategy to have a wider geography of North Slope oil development. So based on the projected reserves of Prudhoe, some of those original estimates were 5 to 10 billion barrels of oil. Of course, today we've moved 13 plus billion from Prudhoe alone, but that would have created a throughput of something like 1.5 million barrels a day from TAPS. So the owner companies knew up front, hey, we've got a little bit of room in this pipeline, right? We can move a little bit more oil than just Prudhoe Bay. So from the very earliest stages of planning for TAPS, industry officials coveted restricted areas like the Arctic National Wildlife Refuge, the Petroleum Reserve, and offshore oil drilling in the Arctic Ocean to maximize the economics of the pipeline. The pipeline was never intended as merely a narrow string transiting Alaska, excuse me. It was designed and built to be a capacious Arctic artery, tapping all of the economic onshore and offshore oil reserves throughout the North Slope. And so this is really fascinating. This is an image from British Petroleum Archives. And most people don't know, there were actually all these surveys done before 1968. To try to figure out, hey, if we discover oil, how are we going to get it to market? And most people also forget, it was actually the US Navy that first discovered large quantities of oil and gas in the North Slope of Alaska. In the 1940s and 1950s, we have Jack Dalton's famous survey in the 1950s trying to bring natural gas down to Fairbanks. We've been trying to get a gas pipeline to Fairbanks for like 70 years. It has been a long time. But Sinclair Oil actually came in and did this survey. I believe this one, there were multiple surveys done, I think 64, 65, 67, all before the discovery of Prudhoe Bay, because the oil majors knew, hey, if we discover oil up on the North Slope of Alaska, the big question is, how the hell do we get it to market? Right. I think George Rogers famously said, the resource might as well have been on the moon based on how far away it seemed to those companies. And based on this, as early as 1964, BP engineers were looking at the Arctic Refuge for possible drilling and thinking about the economics of the pipeline and its development. And on May 4th, 1970, the chairman of Humble Oil, this is Exxon, this is ExxonMobil. His name was Mike Wright. Lots of Wrights out there. He gave an impromptu talk to the Alaska Emergency Task Force, government body commissioned to manage the frenzied development around North Slope crude. And he kind of gave these off the cuffs remarks. And he admitted the oil consortium's plan to build a 48-inch diameter pipeline was, quote, based on the assumption that the highly prospective acreage contained within the Naval Petroleum Reserve number 4, we know this today as the NPRA, the Arctic National Wildlife Refuge, and the offshore Arctic ocean coast will be open to commercial exploration. So the diameter and the design of the pipeline anticipated being able to tap these areas. Humble believed the North Slope contained at least 30 billion barrels of oil. We know that number is much higher today. So I say all of this because, you know, the pipeline was designed with these kind of geographical, this expansive geography in mind. But of course, as Greg mentioned, when we peaked after 1988 in terms of throughput, and Alaska has been dealing with the managed decline, we're dealing with a pipeline here that is a far larger diameter than you would ideally want for the situation. And what's really fascinating to me is, you know, I think in the 2010s was kind of the peak of a lot of this low throughput conversation, right? A lot of concern about low throughput. This could threaten the viability of the pipeline. If you go back in history, some of the first examples that you see of concern about low throughput are actually only 10 years after the pipeline's construction. So in the mid-1980s, the oil industry began a public relations campaign to convince Congress to open up the Arctic refuge. And one of the most fascinating arguments, and one that would be heard with increasing certainty increasing intervals as the throughput of TAPS decline, was that the pipeline itself needed the oil from the Arctic refuge. In an American Petroleum Institute report in 1986, they have one of the first mentions of this novel argument about the lifespan of the pipeline. A decade into the pipeline's life, API said that gaining access to the Arctic refuge would add more oil to the pipeline system, thereby, quote, extending the utilization of TAPS well into the 21st century. And, you know, it's this language also suggested a broader shift in the way that the oil industry and the state of Alaska thought about the lifespan of the pipeline. When it was first constructed, designers planned for the life to operate for 25 or 30 years, as we mentioned. This temporal horizon was based on the projected lifespan of the Prudhoe Bay field. Yet as the Alaska Pipeline's 10th birthday arrived in 1987, advocates were arguing that as long as the line was fed more oil and could continue delivering material benefits to Alaska and the nation for far, far longer. Quote, in some respects, it's like an airplane, contended Alaska's president, George M. Nelson, in 1987. Quote, if you keep rebuilding and replacing parts that need it, the thing will go on forever, end quote. But just like an airplane, the pipeline needed a lot of fuel, right? And maybe I'll just conclude with this part. I could talk about this stuff forever, and I'm just pulling little bits from the book. But it's really ironic because, you know, TAPS emerged at this moment of fierce environmental concern, right? The height of the environmental movement. Wally Hickel was actually here at this university on Earth Day in 1970, talking about an environmental revolution that had swept the country. And the pipeline was ultimately approved on the basis that America needed Arctic petroleum, right? All through the 1980s, the 1990s, even into the early 2000s, Alaska was considered the best prospect for more American oil, right? And then the fracking revolution happens, right? And now the United States is absolutely awash in crude oil. We are not only the world's largest producer of oil and natural gas in the world, we are the largest producer in the history of humanity right now, today. And so the irony is that Alaskans are still very much reliant upon the revenue that comes from Arctic oil. But the nation doesn't need Arctic oil in a way that it once did, right? But what's really ironic is that the pipeline itself very much needs that oil to continue functioning, right? So I'll leave it at that, and hopefully we can have a robust Q&A here, and let me pass it back over to Lisa.
Well, I just learned something new. I didn't know about the 48 inches being that challenging, or that they knew that what they were building would eventually create problems unless they got the oil. Who we have up next is, yes? You can. I'll bring you the microphone, but I'm going to introduce you first. Okay, we have Tim Bradner up next, who was in the 1960s, was a reporter with the Fairbanks Daily News Miner. He was covered early slope exploration and the Alaska Native Claims Settlement Act. From 1970 to 1986, he worked for BP with external affairs in the legislature and the North Slope borough local government. From 1986 until now, he partnered with his brother, Mike Bradner, publishing the Alaska Legislative Digest and Alaska Economic Report. Mike Bradner unfortunately passed away 4 years ago, but he will live on in history. And Tim has a background in political issues with the legislature, with rural Alaska communities, TAPs, environmental issues, and much more. And he's going to bat cleanup. So thank you.
Thanks, Lisa. Listening to that just makes me feel exhausted. Well, thanks for having me here. I always like to listen to guys like these because I learn a lot, and some of you may have seen me scribbling notes as Phil was talking, and you know, kind of habitual reporter, try to remember good things that these guys say, and I learned a tremendous amount, as I will from questions that you guys ask after this. I'm just going to make a few remarks based on my own history and knowledge of this period and these events. I came, as Lisa mentioned, I kind of got my start in journalism at the Fairbanks News Miner, gosh, back in 1965. Had introduction to the early Alaska Native Claims movement and the North Slope. I worked up in the Arctic on the dew line during my college days, and so I had some knowledge of that area, and was in Barrow for a while and met people who came to form the Arctic Slope Native Association, and remained, you know, friends with a lot of them, you know, for many years. Came to Anchorage or Fairbanks to work as a cub reporter at the News Miner, and one of my first assignments that was given to me was to do an interview at the Fairbanks Airport with Robert O. Anderson, who was the chairman of Atlantic Richfield Company, had just in fact organized the merger of Atlantic and Richfield oil companies. And they were one of the early explorers. And I got to go meet Mr. Anderson at the Fairbanks Airport just as they were airlifting the first airlift of a drill rig to the North Slope to drill a well in the White Hills area south of Prudhoe Bay. That was the first well that ARCO and their partner Humble Oil, now Exxon, drilled. A string of dry holes that were drilled that they, along with BP. I was also interested in that because during my college days I also worked on seismic crews on the slope, and one of the areas I worked on was in the White Hills, so I was kind of familiar and interested in the area that they were going to drill in. Turned out to be a dry hole. Along with other ones. And of course, that led to the famous story of ARCO hauling the drill rig off the North Slope. They were disappointed in the results. They were giving up on the slope, and they were taking the rig to Prudhoe Bay to load on a barge to take out. And when they got there, they had picked up some leases at Prudhoe Bay in some of the early state sales, and decided to just drill one more well. Just to, you know, the rig was going by. It wasn't very expensive. Mobilization costs would be cut. Let's give it another shot. BP, meanwhile, had also pretty much given up on the slope, had drilled a number of dry wells, and they had stacked their rig on the Colville River west of Prudhoe, getting ready to ship it out by barge. But that decision to drill one more well, which is well known and famous in the industry's history, really resulted in the discovery of Prudhoe Bay. At the time, it was not really considered a very attractive prospect. Roger Herrera, with BP at the time, remembers that the seismic work on Prudhoe did not look very good. There was a lot of debate within ARCO and Humble as to whether they should really drill it, whether it was worth the expense. Luckily for us, they decided to go ahead and drill it. First discovery was a big gas find because they were drilling right on the gas cap over Prudhoe. They didn't realize there was a lot of oil underneath it. Where they drilled down into the oil, they drilled a confirmation well 7 miles to the southeast, I think, and that was the major discovery of oil. Confirmed the discovery of Prudhoe Bay as a huge oil find. So just, you know, I've always been interested in quirks of history like that, just decisions made by a few people that have really major effects. But while I'm on that kick of giving credit to people for earthquake, earth-shaking decisions, we have to give credit to Tom Marshall. And some of you may know this story. He was the state's first geologist back in the early 1960s. And one of his jobs was to pick out lands for the young state of Alaska to select and for oil potential. Now, Tom was a geologist, and he liked the North Slope and particularly the Prudhoe Bay area because it looked a lot like the places in Oklahoma and the places in the Midwest where he had worked, and he had a theory that there was a lot of oil there and the state should select it. It turned out to be a very controversial decision and a really near miss for Alaska because at the time, Governor Egan was under a lot of pressure from community leaders and mayors to use the state's land selection entitlement to select lands around communities for community development, for ag development, particularly for mining, because the Alaska was pretty much a mining state there in terms of its natural resources. Phil Holdsworth, the first Commissioner of Natural Resources, was a mining guy. And that was the kind of advice Egan was getting. So he resisted the recommendation from this young, oil geologist, Tom Marshall. And but Holdsworth wound up backing him up, and it became a big argument within the state. Egan resisting it, Marshall and Holdsworth, and eventually a few others arguing to go ahead with the selection of Prudhoe Bay. Oddly enough, and Marshall told me this himself, that the oil companies, which had also were becoming interested in the North Slope, were resisting the idea of using the land selection around Prudhoe because they weren't sure it looked very good either. They wanted the state to use its land selection title around Umiat, which was the original in early National Petroleum Reserve exploration discovery by the Army. They thought, the best place to look for oil is where oil's been found. And Army had found some oil at Umiat. So they thought, let's drill around there and let's use this land selection entitlement. Well, it's a good thing that Egan finally went along with Marshall's recommendation to select lands around Prudhoe and not Umiat, because Umiat turned out to be a pretty poor prospect. There would have been more dry holes drilled around Umiat. So anyway, that kind of set the stage for the interest by BP, ARCO, Humboldt to drill on the slope. Eventually led us to Prudhoe Bay. Interesting little history as to how small decisions by individual people can have big impacts. So we owe credit to Tom Marshall, to Phil Holdsworth, Governor Egan, eventually to went ahead and approve those land selections. I want to say a couple things about the early controversies around TAPS. We, we're all familiar with how the environmental groups, conservation organizations fiercely opposed the pipeline because they were concerned that it would break. There would be massive oil spills up and down the line, disrupt the wildlife, interrupt the caribou migrations. It was as you all remember, it was a big fight. Well, and we all know that those pressures in the late 1960s led to basically to the pipeline being built safer. A lot of pressure on the government to put pressure on the companies to ensure the design and that it was built with a very sturdy design, and that's proved as well over the years. In fact, as Greg mentioned, TAPS has been just an amazing engineering accomplishment for, over the years. All of the innovative designs that were built into it have proved very durable, and they all worked. The lateral support members that allowed the pipeline to move as there was expansion and cooling. It worked great. It also is an earthquake design, worked extremely well during the Denali fault quake. We've never had a pipeline break. We've had, the one corrosion incident at Adigan Pass. And of course, the Prince William Sound spill, which was not really a pipeline, it was a tanker incident. But the pipeline has been amazing in working exactly as planned, safely, no real problems. We have benefited obviously greatly from it. One other little historical note that I'd like to make, the university itself, Greg mentioned the university playing a role with the pipeline in terms of earthquake advice and geotechnical advice, but what's probably not as well known is that in 1969, one of the first major Alaska science conferences, at the time that there was a huge national interest in the pipeline and the environmental issues, was held here at UAF. It was the first time that a lot of company executives came up to it. A lot of university people obviously were forefront. A lot of the government scientific community was here. And that was the first time that people really came to face the challenges of permafrost and the environmental conditions. The companies were not really that familiar yet with Alaska, and it was the first time that really they met face-to-face with UAF people who had done a lot of work on permafrost. And of course, there were a lot of presentations during the conference. I was here, actually. The real discussions, though, took place, off the cycle in the side discussions that went on. And out of that came a very serious involvement by the university and its people in working with, at first it was called TAPS, and then it became Alaska, in terms of the design and dealing with the permafrost. With the vertical support members design, of course, the industry was heavily involved in that, a lot of innovations, but a lot of the work on permafrost and the how to deal with it came from the university. And so, over the years, UAF has played a key role in making sure the pipeline is safe and is operating soundly. Anyway, interesting history, and and not that many people give UAF credit and university credit for its involvement in the early days of the pipeline. One more little vignette I can't resist passing on is I think it was in the map that Phil showed. A lot of the early route planning for the pipeline went through Anativik Pass. And the map, I think that Phil showed, put together by Sinclair, had the pipeline going through Anativik. And that was really the conventional wisdom among the companies when they, early days, 1969, 1970, when they first began thinking about TAPS and how it would be built. It was when the pipeline folks came to Fairbanks and they met people at ISCR here. Yeah, I think ISCR had just been formed. Vic Fisher was the director, and Vic advised them to go to Barrow and meet with Max Brewer of the Naval Arctic Research Laboratory and just talk about the environment and the challenges of doing things in the Arctic. And they did. And a friend of mine at the time who was working at ISCR, Terry Brady, went along with him, flew up to Barrow. And the company sat down and they talked to Max about, how their idea for the pipeline and where they would build it. And Max advised them that there was another pass in the Brooks Range that they should take a look at because it might be shorter, although it would be more difficult to build it. And that was Adigan Pass. And at the time, now this is according to Terry, who was there in the conversations, the companies had not really thought a lot about Adigan Pass. And so they got back on the plane and they flew over and looked at it and flew around. And they admitted, yeah, it's going to be difficult to build through here, but it is shorter and it might be more feasible. So anyway, that's a little vignette about how we kind of got the pipeline from Anativik to Adigan Pass. Terry, by the way, a longtime resident of Fairbanks, remembered that, a lot of hunters in Fairbanks flown around up there and hunting, and they knew about Adigan Pass, but the industry folks did not. By the way, one of those hunters was Chuck Gray, who was the longtime manager of the commercial printing in Fairbanks, and Chuck was a big wolf hunter up there, but he knew all about Adigan Pass and talked about it a lot, and was talking about how that would be a better place for the pipeline to go through. I think Chuck is still with us and retired here and still living here in Fairbanks. Anyway, that fun little stories from the early days. One thing, I'm going to just mention one more thing about early days, and then we can launch on to some good Q&A. Pipeline impact, in terms of the politics of the pipeline, right off the bat, the impact of building taps on Fairbanks and Valdez was a huge issue for the state, because the municipalities did not really have the resources to deal with all the thousands of construction workers that came through. I mean, we all remember, a lot of us who were here at the time remember what Fairbanks was like in those days. I mean, you couldn't get a hotel room. But what came to be known as 2 Street was very colorful and very crowded, and a lot of pressures on housing. I mean, it was hard to find labor. All people working for local government, took off immediately for better paying pipeline jobs. Very difficult to recruit people. Governor Egan was very concerned about helping the community, helping Fairbanks and Valdez pay for that. And we eventually did get some additional state resources up here to help pay for that. But the impact of the pipeline was a big deal in those days. And as we have talked about other projects like the gas pipeline, that was really forefront in people's minds. It just isn't building the pipeline. You have to deal with the impact, and you have to make sure it's paid for. Alyeska, to its credit, was really quick to help the state repair the Richardson Highway and make all the repairs and that will play on if a gas pipeline is ever built. At the forefront of that planning is the mechanisms to repair road damages, damage to bridges, ports, and to other public facilities that are used. Of course, we have yet to see a gas pipeline, but back in a few years ago, when it was very actively being considered, a lot of work was done on analyzing the impact, and particularly on how it would be paid for, and who would pay for it. And the consortium, the industry guys were always up front. Yeah, we'll pay for it. We caused the damage. We'll pay for it. Anyway, a few kind of fun dialogues. Anybody have any questions or comments? And
Yes, questions? Hello. Oh, I see several. Hang on. Oh, gosh, Marty, I won't say no to that. Thank you.
Was it? Oh, hi.
Hi, I'm Doug Pope. This is for Mr. Kinney and maybe for Mike, or maybe for Tim, sorry, Tim. So I heard you talk about seismic activity on the pipeline, but I thought you kind of minimized it because you went by it so fast. In 2002, I was working with an expert structural engineer, and he called me up, said, I got to leave because of the earthquake. And he told me at the time how much the pipeline had actually moved from its original location, I'm just wondering if you could kind of give that information to the audience to give them a greater appreciation for how well the pipeline was designed to deal with that kind of movement.
Shit, I don't have a microphone.
Yeah, just more of a function of time than anything else is the reason why. I don't remember the exact displacement of it, the pipe at that point, but it was very significant. I want to say something on the order of 15 feet. I don't remember offhand, but that's really significant for, and if it was just on conventional vents, the way that most of what you see is, we would have had some real problems with it. In fact, we did have some problems. Some of the problems, as you might have witnessed, were up slightly north, and where the actual rupture happened was at almost the extreme northern end of the fault zone, crossing zone. In fact, there's a wayside over there that you can go to today and see. There's in fact an exhibit, but it was almost at the northern end, within that 3/4 mile area. But north of that, we had a couple of shoes that were knocked off. I want to say there were maybe 2 of them. Do you remember, Dave? And our design criteria is typically we can withstand displacement so that we can lose as many as 3 of them and still be fine in terms of the sag in the pipe. We won't end up overstressing it. When I say overstress, that means maybe getting it to yield, So this certainly wasn't trivial. And it was an area, something that involved a hit squad of just some all-star seismologists. I want to say Bruce Bolt, Doug Nyman, a lot of names that we have worked with in the past, world-class geotechnical engineers and geologists all converged on Alaska. And that was about the next 2 to 3 years, and it included seismic evaluation of other potential fault areas. I want to say there was one additional fault that was actually discovered during that exploration. And we also got better characterization of some adjoining faults to include like the Donnelly fault that had been previously identified as a crossing zone. So does that kind of get at the little bit more detail? Yeah, thanks. Yeah. There was, this was an area of focus. The seismic design of taps was world-class at the time, and large credit goes to some of the engineers that we were working with out of the University of Illinois, Nathan Newmark, and his team, as well as a lot of geologists out of the USGS in Menlo Park. So this was truly an area where scientists and engineers came together.
I'm Karen Purdue from Fairbanks. I actually worked at Franklin Bluffs and Galbraith Lake. And of course, I was a lot younger, 50 years ago. And I was a Teamster. And it really changed my life. It really gave me the money to go to college. We were in Fairbanks and it was an overwhelming situation. The phones didn't work and all those things. But the positive side of it was a whole generation of young Alaskans got employment opportunities. Some of them stayed in the trades and some of them didn't, but it was a pretty amazing situation. The point I want to make about the university and Alyeska or the pipeline is I had the opportunity to work at Galbraith, and then I went, as a regent, I went back to Tuluk last summer. And it is a world-class research facility. And there's no way that the science would be able to be supported without that facility because it's an Arctic environment. And my understanding is that Alyeska or the state or both worked right after the pipeline to gift that to the university. And that is a really huge testament. There are research projects that have gone on for 40 years right under the pipeline. Ground squirrel research. There's, climate research that's been going on for 40 to 50 years. So it's a testament. And as Alyeska looks forward to celebrating its 50th anniversary, think about Tulik, because it is a real partnership of science and industry. And you look across that huge valley and you see that pipeline, and you see the the mountains and the camp, and you realize this is it. It's all in one picture, how environment and industry done well can lead to long-lasting sustainable research. That's my advertisement.
I'm Dave Norton. I just wanted to add a couple things to what Greg said, talking about the earthquake. Question about the earthquake was mentioned the 30-year TAPS right-of-way renewal process was ongoing at that particular time. And it was an EIS process, NEPA process, just like the original one. The first one was done was TAPS. So we're going through this environmental assessment process, and it was going fairly well because you could, rather than having a prospective project where you're trying to forecast impacts of a project, we already could see impacts. We could extend those into the future, whatever impacts there were. So it was going along pretty good, except for earthquake seismic design. The government was telling us, well, yeah, you had state-of-the-art seismic design for the pipeline in 1971, but here it is 30 years later, and we're looking at earthquake damages in California and other places, and they're seismic bracing buildings and freeway overpasses and things like that. What are you guys doing? Why aren't you putting like a third VSM leg and all these, to strengthen the pipe now that you know more, like we all know more. So we were kind of we weren't at an impasse, but we're getting close to being an impasse with that debate. And then the earthquake hit, and the Denali Fall crossing performed exactly as it was designed. And after that, there was no more questions about seismic design, and we were able to get it done. The other thing I want to point out was on the economic life of the pipeline. The useful life of the pipeline is usually a combination of economic and physical life. Physical life is indefinite. Economic life is when the cost of operating and maintaining the pipeline exceeds the revenue from the oil stream, that's the end of life. We don't know when that is. It's going to be a long time from now, probably. And as far as the lower throughput, it's even if right now it's like 500,000 barrels a day, say 50 years from now it's 200,000 barrels a day. That's still a very large field anywhere in the United States. And so there ought to be a way to figure out how to move oil through a 40-inch pipeline at low throughput. But the thing about the pipeline, when it was authorized and built and started pumping oil, it was there was an oil crisis that was the impetus for it. And when a pipeline was operating, Greg, I think it was the throughput of TAPS was 20%, 25% of the nation's oil demand. So it was the big deal. Now, lower throughput and now more production in lower 48, it's not that anymore. So back then it was a big deal for the United States. Now it's a big deal for Alaska still.
Yes, in that direction.
Just a quick question. Early on, when we were talking about the pipeline, a lot of discussion occurred around removal of the pipeline. I hope it's going to be hundreds of years from now. But I remember hearing that there was a fund out there to pay for the removal of that pipeline. Apparently, that's not true. And now the pipeline has changed hands and it's owned by somebody else. Who is responsible for removal of the pipeline? Hopefully, it's 100 years from now. But where do we stand now on that?
Thank you for the question, Senator Stevens. And yeah, just, as from a historical perspective, this pipeline has been called the eighth wonder of the world, but people have also said it's the only wonder of the world that contained within its approval the seeds of its demise, right? Which was the promise that when the pipeline is done with its useful or economic life, when it's at the end of its days, nobody knows when that is, but it's a question of if, not when, that the land will be remediated and restored. And so there's a few questions around this because that has not been defined what that looks like, right? Does the pipeline stay there as a museum, something like that? I think the biggest question is around the fund that you ask about. All throughout the history of TAPS, the tariffs have been paid to ship that oil. Funds have been collected ever since the first barrel of oil moved through in 1977 for that decommissioning, that eventual decommissioning. I think it was expected that those funds would sit in some type of trust fund, some type of escrow trust fund, but that was never set up. So those funds are interwoven with the corporate owner's finances. And as you know, this presents quite a challenge for us today because BP, arguably the most important oil company in Alaska's history, right? They own 50% of TAPS, operator of Prudhoe Bay. They are no longer doing business in the state of Alaska, right? And Hilcorp bought BP's assets. Hilcorp is about 2% the size of BP. Nobody expected that Hilcorp could take on the DRNR obligation from BP. So BP retains that obligation. Arguably, BP owes the people of Alaska about $3 billion right now. They don't do business in the state. How are we going to get that money when the time comes? Is BP going to be a company when that time comes? I think these are really important public policy questions that we need to think about. And from a very basic perspective, I do think those funds need to be escrowed so that when the time comes, they are available for what they were originally intended for. Yeah, Marty.
Isn't it fair to say that they were accounted for by the companies, not collected?
Yes. So
Yeah.
those funds don't actually exist in an account.
Yeah. That's correct. And neither with the feds or the state. And just for a couple further comments about that. When we renewed the TAPS right away for the 30 years, I was handling it on behalf of DNR in the state. And basically prior to that renewal, the federal government had the owner companies on the hook. The state of Alaska did not. We had the local operating companies, but I was able to get that one thing changed. So the corporate heads of the companies are now on the hook, although didn't change the collection or not of the funds. So that was a critical piece of it. So.
I just had a comment about this and maybe a question, maybe for Marty on this. The so-called DNR rehabilitation issue has been around for a long time, and some of you in Fairbanks will remember Richard Feinberg, a late journalist based in Fairbanks, who has written a lot of articles about this. Really brought it out to the forefront of the political consciousness. But Richard, of course, was arguing, as others have, that there should be an actual fund established for the DNR. The companies resisted that. They said, look, we've got the responsibility. Why do we have to tie up capital in a separate investment fund? And that sort of thing. And this is more a question. I seem to recall that there's a long history of this in the mining industry also, that when mines are built, that funds are required to be set aside for restoration. And a lot of work has been done on the standards for habitat restoration also. But is that the case, Marty? Is there a fund for Red Dog Mine, for example?
Yes, there is. The state started imposing some bonding, if not set aside some sort of escrow account, but primarily it's in the form of bonds. But it doesn't go all the way back. I mean, I think it probably was initiated around the time of Red Dog. So, but it's based on a reclamation plan. So that reclamation plan is directly linked to the bonding amount. And it's, you know, obviously the companies are not very interested in tying up huge portions of capital. So that's a constant tension. And how much remains and all that is also an issue. The other thing just a couple of comments associated with what we call DR&R, that's this whole rehabilitation issue. The companies have always had a problem with the idea of setting aside an escrow account for TAPs, and I understand that. But on the same time, they also argue that they want the state and the federal government to be specific about what we're going to require of them, so that they can, you know, lock in a particular form of action. For the state of Alaska, it's statutorily left to the discretion of the commissioner who's in place at the time of the DR&R action. So they could determine that at that time that they wanted every pebble removed, or they could, as you say, turn it into some sort of a historic facility. Anyway, but it has up to now been something that has been left totally discretionary, and it's a calculation that they go through. Mhm.
Thank you, Marty. I'm Mike Music from the People's Republic of Esther. And I want to respond to Doug and Greg here a little bit. Back in the day when you were designing the crossing there at the Denali Fault, John Davies was the state seismologist. And I know he participated in identifying the magnitude of the potential quake there. And in 1976, I built a cabin about a half a mile south of the Denali Fault down the Richardson. And I can attest how much the ground moves. When you walk out to where my driveway hit the highway and look to the north, the east fog line was lined up with the center line of the north. I don't know how far that is, but it's somewhere in the 14-foot range, I guess. That's how much the ground moved. I think the pipe whipped back and forth on those long Teflon pads, 20, 30, 40, 50 feet maybe, before they knocked down the VSMs to the south. And it was quite a dramatic ground movement. And my cabin ended up 3 feet away from my stack of wood that used to be under the eaves. Now it's out in the rain. But my friend Hillary Schaefer was working at Pump 9 then. She was an environmental specialist there, raced down to, oh, I don't know, 10 miles or so. No, more like 20 from Pump 9. And there was no oil on the ground. What a relief. It was that close, but our engineers really did the job. And I got to take my hat off for that.
Glenn Seaman, I was very interested. It was very interesting to hear that they almost went right by Prudhoe Bay and didn't pick it and such, and that that was interesting. I question though, and I'm totally ignorant on the engineering stuff, so a question for Greg. How come the seismic work that was done in Prudhoe didn't detect this massive amount of oil? And is that just how the process goes? I mean, does that seismic work? I don't know the limitations of that. I was just interested.
When I talk about geology, I'm getting into dangerous territory. It limits my knowledge. But all I know is just my discussions with Roger Herrera at BP, who is one of the early geologists that worked on Prudhoe and other North Slope work for BP. And Roger said first off, the seismic at the time was pretty crude compared with what we have today, and it detected a very subtle. I mean, these structures are difficult to really interpret and see sometimes from the surface, and it showed a very subtle anticline. They weren't quite sure it was really there. They thought it might be just a bad reflection of the sound waves through the permafrost. A lot of debate within BP over that, and so they just weren't really sure. The art, and it is an art of interpreting seismic data, was very early, very rough at the time. So we're just lucky that they wound up, BP decided to go ahead and go with the recommendation of other geologists that there really was something there. And then that, led to the decision by Arco and Humboldt to respect that and go ahead and drill. Does that sound right to people who know more about this than I do?
It does. I don't know.
Oh, and then click. Send.
Thank you. I was here during the pipeline as well, and unlike Karen, I was down at the Palace Saloon serving beer at age 19. I was a brand new legally drinker. But my question has more to do with the social environment of the pipeline and what it has to do with our modern psyche and the problems that Governor Walker was talking about this morning. There seemed to have been a switch that flipped, because building up to that point, we loved our schools, we paid for them. I went to graduate school on scholarships from funds that predated the Firmament Fund dividend. There seemed to just be a psychological shift, and it related to the pipeline. When we graduated high school, you could get a $50,000 a year job going up from $350 minimum wage at that point with no skill, and a lot of my friends did that. And I just think it created a level of expectation that we've not been able to maintain. So just was interested in what your views would be on that.
Thank you for the question. Yeah, a few different thoughts. One, the pipeline absolutely transformed Alaska, right? Doubled the population, changed the character of the state, changed the character of the people who are here. Some of that came different views about the appropriate role of government. I think, our conversation this morning around getting rid of the income tax and that disconnect that created between citizens and the state is alive and well with us today, unfortunately. I think that, I've often heard the argument that Alaska is the last place where you can still get a 6-figure job with a high school education. I don't know how true that is anymore, but we've seen a dramatic progression in the nature of work in our economy all throughout the country, and Alaska is no different. Maybe the last thing I would say is, and Terrence Cole talks about this again in the wonderful paper that you're all going to read for homework, Blinded by Riches. There has come to be an expectation that we will find another supergiant. We will build another pipeline. We will have another cash cow. And Terrence Cole's point is, Prudhoe Bay was a one-off. We got really, really lucky, and we cashed out on it, and we should not expect anything like that again. And if you go back to the origins of Alaska statehood, it was about creating this natural resource development machine and using those funds to support the long-term well-being of the people of Alaska. But Terrence's point was that, Prudhoe Bay is the exception. And so I think as we look back, if we continue to have expectations that everything's going to be like 1979 to 1983, yeah, we're going to be disappointed.
Say one more thing. I can't resist adding on to that. And by the way, I know Click's been waiting on a question over here, but just referring to expectations of another giant Prudhoe Bay discovery and the discussions earlier about ANWR. Yes, there was a lot of industry interest in ANWR in the 1980s, and we know that BP and Chevron drilled the only test hole over there. It was on Alaska native land, but it plays into this whole controversy or whether ANWR should be opening or not. It's interesting to me that since the late 1980s, there has been very little interest by the major oil companies in ANWR. True independent companies, the state of Alaska has been very promoting it. Our congressional delegation has always been talking a lot about it, but the interest by BP and Chevron sort of went poof, and I think it had something to do with that KIC well that was drilled, the results of which have never been publicly released, but the kind of the grapevine is that the results were not particularly encouraging. That's not unusual with a new wildcat in a wide open area. So undoubtedly there's some oil in ANWR, but a lot of petroleum geologists now, or at least some believe that, while there may be modest discoveries in Anwar, that another supergiant discovery is unlikely. And that's pretty much played out across the North Slope too, even in the National Petroleum Reserve. Discoveries like Willow will be there, but not Prudhoe Bays in all likelihood. Anyway, I know Click's been waiting. Sorry, Click.
See you, Marty.
Senator?
How you doing?
Good.
A lot has been said about the engineering on the 2002 Denali fault line. And thank God for the engineering and everything we learned, but somebody had to make that weld. And I want to stand up and say thanks to the working men and women of Alaska that built that pipeline, that made every one of those welds and consequently no leaks on taps. And another thing that I wanted to just mention here briefly was, let me get my notes here. A lot has been said about the environment. And I remember as a young kid, when the taps was being discussed, there were some editorials coming out of Wiseman from some people I know about the amount of trash that was going to be on the Hall Road. Well, it's been, I don't drive it all the time, but I drive sections of it. I don't see the trash that people had talked about. I think people take a lot of pride in that Hall Road. It is pristine. The last thing I want to say is I love history. I've read all the books you're talking about, and we could have this conversation for the rest of the night. But there's a good book written by Mim Dixon, What Happened to Fairbanks After the Pipeline. And I used that book in the legislature when Marty and I were working together, advocating for workforce training dollars, and used some of her quotes to lobby the legislators to support our funding. So thank you. Go, Marty, go.
I just want a few comments for Tim. You know, firstly, Tom Marshall was really important, but you know, Gordy Herod was the first state geologist, and he immediately hired Tom Marshall because he understood that you had to have a good petroleum guy. And secondly, Marshall's idea was the Canadian Foreland province near Alberta, you know, the Ladue discoveries, and then up the Canal Pipeline, Mackenzie, it's all the same geology as the North Slope. And so he understood that as an arcuate path, and that was his argument, his geological argument, that they were going to find something up on the North Slope. So, another comment I have, in 2023, I took a bunch of geologists from all over the world on our road systems, the Kenai Peninsula, the Glen Highway, the Richardson Highway. And I left them at Quartz Lake, and someone else took them up to the slope. But they saw the pipeline. They saw a lot of it. They saw where the Denali Fault, where amazingly there was no rupture. They saw the pipeline across the Tanwell River. And the final comments they made to me, and one of them in particular, the director of the Geological Survey of Romania told me, this thing looks like it was built yesterday. And it says, 50-year-old pipelines do not look like this in other locales in the world.
She's talking.
I hope that all of you had a chance to take a look at the special exhibit at the University Museum. If you haven't, with your name tag, you can get in there. But take a look at how they're using all of the satellite data to look at the surface of the Earth and how the glaciers are changing and how all of the geology and the earthquakes are being affected and how they're reading that as we speak. That's why these technologies are aiding us. But you have to see that exhibit to understand how dramatic that is.